how to write the program, in assembler, and how to uh, execute it. So those things we'll see them. Okay, so you have to follow certain steps in order to execute a program by writing that in an assembler, by supplying the program to the assembler. So in early days, people used to write the programs using a machine language, it used to consist of zeros and ones. Later, assembly language, which provides mnemonics. So an assembly language program consists of series of lines, assembly language instructions. Okay, if you see this, this is what is an example for assembly language. Okay, program. Here in assembly language, a series of lines. These are called as instructions. This is one such mnemonic. This is the next mnemonic. This is the next mnemonic, like that. These are all instructions. These are all instructions. Okay. And program consists of two things. One is a set of instructions, and the next one is going to be directive. So directives. Directives means here org is a directive, end is a directive. So these are not instructions. These are not instructions. These are they are the pseudo codes. They are the codes which will direct the assemblers. They will guide the assembler. Okay, they guide the assembler, but they are not instructions. What is meant by instruction? Now, if you if you consider move a comma 05, you are instructing the microcontroller what to do by writing an instruction like move a comma 05. Initialize a with 05. Initialize b with 06. There is a difference between 05 and 06 here. 05H is not there, which means 05 is a decimal number. 06H. The 06 is a hexadecimal number. Now I have written, I have initialized B with initialized B with 6. Okay, so INITI initialize B register with 06H. Okay, so this is what is the comment, the single line comment. Now you can comment a particular text by writing one semicolon symbol, by putting one semicolon symbol or two forward slashes. And if you want to comment multiple lines, this is a procedure to comment multiple lines. Okay, so here these are instructions, and END and org, they're called as directives. And often assembly language program is also called as low level language. Okay, and given assembly language program is a series of statements or lines. So assembly language means it is a series of lines, a series of instructions. Okay, and these assembly language instructions tell us what to do. Assembly language instructions will tell the CPU what to do, whereas directives, they are not instruction, they are pseudo codes or pseudo instructions, give directions to the assembler. So what is meant by an assembler? Assembler is a program which converts the assembly code or mnemonics into the machine codes. Okay, so you have to follow certain steps in order to uh, assemble a particular program, in order to execute a particular program in the assembler. First thing is you create. First thing is, I'm just deleting all these sort of things, all these files, whichever is necessary, that only I'm just keeping it. Remaining all the files, for your understanding sake, I'm just considering only one program. Okay, so this is what is the ASM file. This file. So I've created one ASM file, first program .asm. .asm means assembly. .c means C program. So I've created one .asm file in Notepad. Okay, so this is what is my assembly program. Okay, this program is to add two 8-bit numbers and to store the result in R0 and R1 register. Now how to execute this particular program in the assembler? The first step is write the program in any of the editors. So I have written the program in the notepad and I named this particular file first program.asm. So that is the first step. Second step is you supply this particular program to the assembler. If you give this particular program to the assembler, so what the assembler will do is assembler will create object file, then LST file, list file, then it will create one ABS file, and then finally it will create one hexa file. So what is the first thing that it will do? It will create one object file, and then it will give you the list file, then it will create absolute file, then finally it will create one hexa file. So this is what is our requirement. So after getting hexa file, okay, we write this hexa file in the ROM of the microcontroller. We write this particular hexa file in the ROM of the microcontroller. Okay, the purpose of assembling the program is to get the hexa file so that we can write it in the ROM of the microcontroller. So we'll try to understand that with the help of this flow chart. First, we take proper assembler and we give this ASM file. That assembler will create list file, object file, absolute file, then finally it will give you the hexa file. This hexa file we'll put it in the ROM of a microcontroller. Now I'm just going to show you another simulator. So this is what is a simulator. Okay, simulator where I already have created one particular project file in this for your convenience. So I just have considered one particular microcontroller. I'm going, and this is an 8-bit microcontroller. This is an 8-bit microcontroller, which is going to have 4 kilobytes of ROM. 4 kilobytes of ROM. This 4 kilobytes of ROM, I'm going to utilize it. I'm going to write the hexa file created by the assembler in this particular ROM. Okay, so now I'll just take assembler. So the assembler that I'm going to use is a Keel Microvision assembler. It is asking me the permission. Say yes. Okay. Say yes. Now I'm supplying the assembly file, ASM file. So right click on this and add files to the source group. My file is a ASM file. So file type is ASM. So this is the assembly file which I have to supply to this assembler. Say add. Okay, and then close. So I have given this particular file to this assembler. Okay, I've added this particular file to this assembler. Now if I click on build, rebuild and translate these three buttons. So what it will do is it will create okay, LST file, OBJ file, and then hexa file. You can see here creating hexa file from classworks. So once after supplying this ASM file, if you click on build, rebuild and translate, then what it will do is it will create, the assembler will create LST file, OBJ file, and then ABS file, then hexa file. You can see in this particular folder, I created one ASM file. It created LST file, OBJ file, and then the hexa file. And the hexa file is created. This hexa file, I'm going to write it in the ROM of the microcontroller. So here, this is what is the microcontroller. I'll double click on this and then click on this particular thing. You select the hexa file and say open and then say OK. So what you have done here is by doing this, you have burned this particular IC with the hexa file. You have written a program inside the ROM of this particular microcontroller. So this is means you have written one particular program in the ROM of the microcontroller starting from 0000H onwards, 000H onwards. Soon after you give the power to this particular microcontroller, the program will get executed. So this is how we can use the instructions as well as the directives. There are many directives are available, not only yeah, what you call it as ORG and END. ORG is a directive which is used to indicate the beginning address of the program and indicates the assembly at the end of the ASM file. And EQU, this is used to define the constant without occupying the memory location. EQU directive does not set aside, means it doesn't require any extra space for that. EQU example you can see here. You can see here that is count equal to 25. So count means 25. Move R3 comma hash count. In place of count, assembler will consider 25. Will consider 25. It is equal to count is equal to 25. Wherever it come across count, it will put that 25. Okay. So this is how the directives going to be utilized by the assembler in executing, in understanding the program. There is one more directive called as DB directive. DB means data byte. Okay, so data 1 colon DB 28. So DB hash within quotes 2591. So like this we can we can use this DB directive. When DB is used to define a data, the numbers can be decimal, binary, hex, or ASCII. Write short notes on directives means you just have to tell what is the directive, give the information about DB directive, ORG directive, END directive, EQU directives. Okay, EQU, all these are directives. They are not instructions, they are the pseudo codes, okay, which will direct the assembler to how to understand that that program. Thank you very much.